Okay, Unit 9, Day 3 is about inscribed angles. Okay, before we get into inscribed angles, though, we got to review a couple things really quick, specifically arcs and central angles. So in this circle here, all the way to the left, if I draw an angle in here, like this, and I have a central angle right here, and let's say that central angle is 120 degrees. First thing I want to review is that I can either put that central angle in the circle itself, and it just refers to the angle created by these two line segments, or I can write it up here. I can write it on the outside of the circle. When I write it on the outside of the circle, what that 120 degrees is saying, that's the angle covered by the arc that goes from A to B. The other thing is, all angles inside of a circle have to add up to 360 degrees. In other words, all central angles, if I add them all together, they'll total 360. So if this angle right here is 120, and I want to know what this angle right here would be, the easiest way to figure that out would be to subtract the angle I already know, which is 120, from 360. That's going to tell me what's left over for this blue angle right here. So if I were to do that, what I would see is that this angle in blue would have to be 240 degrees. Same thing over here. If I have an angle, maybe my angle this time looks like this. If I said that that angle was 125 degrees, then I can either write it right there or I can write it over here. And what I'm saying is that the arc that I'm highlighting in yellow covers 125 out of the 360 degrees inside of this circle. And the way I would write that is I would say arc AB 125 degrees. Okay, and then if I wanted to figure out the measure of arc ACB, in other words, the major arc here, I would just subtract the 125 from 360. So 360 minus 125. So this would be 235 degrees. In other words, major arc ACB would be equal to that 235 degrees right there. The other type of arc that we talked about was just diameter, the arc created by a diameter. So remember, a diameter is just a straight line that goes from one side of the circle to the other, passing through the center. So this red line that I've drawn on the circle all the way to the right is a diameter. And it goes from A to B. And since there's 360 degrees in a circle, and the diameter divides the circle into two perfectly equal parts, both arcs, or both central angles, are going to cover 180 degrees. To visualize that a little bit differently, this yellow arc right here from A to B is going to cover 180 degrees of the circle, as is this sort of light blue arc. All right, new stuff. An inscribed angle. So an inscribed angle, remember, inscribed means like written within. So an inscribed angle is an angle made by two chords with its vertex on the circle. What does that mean? Well, a vertex is sort of like the middle point in an angle, or it's where the two line segments come together. So if I look at this circle on the far left, and I have ABC right here. I have chord AB, and then I have chord CB. They meet at point B right there, which is the vertex of angle ABC. As you can see, angle ABC intercepts arc AC. Okay, so here's how this works. If I know, for example, that arc AC right here is 130 degrees, then angle ABC is going to be that divided by 2. In other words, if arc AC covers 130 degrees, angle ABC is going to be half of that. So half of 130 is 65, and so angle B right there would be 65 degrees. Here's another example. Triangle, or the circle in the middle. I call that A, I can call this B, I can call this C. And obviously, again, I have angle ABC right there. If I know that angle B down here, angle ABC, let's say I know that this angle right here is 40 degrees. Well, by the same logic from the last one, I know that this arc is going to be 2 times as big as whatever the angle is. And so arc AC is going to be 2 times whatever angle ABC is. Angle ABC is 40. 40 times 2 is 80. Over here, I have another circle with another inscribed angle. And again, I'm just going to call it ABC. The inscribed angle here is at B. If I know that arc AC, let's say I know that arc AC is 90. Let's say arc AC is 90 degrees. I know that angle B down here is going to be half of that. Half of 90 is 45. Okay, so a couple of formulas to write down. I'll put them down here at the bottom. If I start with an inscribed angle, the arc is just, or the inscribed angle, let me back up. If I want to know what the inscribed angle is equal to, it's whatever the arc is divided by 2. So like when this circle over here at the left, the inscribed angle here, ABC, is the arc 130 divided by 2, which is 65. If, on the other hand, I want to know what the arc is, I just take the inscribed angle and multiply it by 2. So right here on this middle circle, I knew the inscribed angle was 40. To find the arc that it intercepts, I just multiply this 40 by 2 and get 80. So to fill in the blanks here for you, an inscribed angle is equal to half the measure of its intercepted arc, and an arc intercepted by an inscribed angle is 2 times the measure of the inscribed angle. Next rule. If an inscribed angle intercepts a 180 degree arc on the circle, then that angle is 90 degrees, or I could say right. In other words, it's a right angle. Okay, here's an example down here at the bottom. If I call this point A and this point B, and I can see, and I could call this point C if I want to, I can see that angle ACB intercepts an arc that goes from A to B. So just ignore this line in the middle for right now, right? If I just pretend that I have chord BC and chord AC, I just have these two to start with. I can see that those two chords intercept an arc that goes from A to B. If I know that that arc is 180 degrees, then what that means, by the rule that we learned on the last page, this angle right here is half of that intercepted arc. Half of 180 is 90. So this, in this case, if I know that arc AB is 180 degrees, angle ACB is going to be 90 degrees. What that means is that anytime you have an inscribed angle that intercepts a 180 degree arc, you've sort of created a right triangle inscribed within that circle. So triangle ABC is a right triangle. Why does that matter? Well, it means that if I know, for example, that chord BC is 4 and I know that chord AC is 5, I can figure out the diameter of the circle, right? That's all this is right here. AB is just the diameter of the circle. So if I want to know what the diameter of the circle is, I'm just going to use the Pythagorean theorem. the side across from the hypotenuse is c. I can call that one little a, this one little b. So I would just have 4 squared plus 5 squared equals c squared. And so if I go ahead and work that problem out, I would get to 41 equals c squared. I would take the square root of both sides. And I would see that c, in other words, the diameter of the circle, would be about 6.4. What's nice is if I know the diameter of the circle, I can find the circumference. So let's say I want to know the circumference of the whole circle. Remember, circumference means how far is it, what's the length if I start at B and went all the way around the circle once. Circumference is just pi times the diameter. Oops. And I know the diameter is 6.4, so I would have pi times 6.4. So the circumference of this circle would be about 20.11. So the diameter would be 6.4, circumference about 20. Last rule with inscribed shapes, inscribed polygons in a circle. If I have a quadrilateral inscribed in a circle, quadrilateral just means a shape with 4 sides. If I have an inscribed quadrilateral, opposite angles, so for example these two, and I'll give them some points. So A and B are going to be supplementary. And if you forgot what supplementary means, it means 2 angles that add up to 180 degrees. So in other words, if angle A right here is 88 degrees, angle B would have to be 92 degrees, right? Because if I add 92 and 88, I would get 180. Same thing going the other way. This angle and this angle are also going to be supplementary. So I'll just give those names really quick. Angle C and angle D are also going to add up to 180 degrees. So if angle C is 110 degrees, angle D would have to be 70 degrees because those two together would add up to 180. All right, a few examples of the type of problem you might see on the test that are related to what we've covered today. First type is really simple, right? Remember, if I know an arc intercepted by an inscribed angle, right? And I want to know what that angle is. To go from arc to angle, the angle is just the arc divided by 2. So angle B is just going to be 60 divided by 2, which is 30. Okay, so angle B right here is just 30 degrees. On this one, now what I have, I'm starting instead with the angle itself, and I want to know what the arc, what the measure of the arc is. Okay, well, if I want to go from angle to arc, in other words, I want to know what the arc is equal to, it's just the angle multiplied by 2. So I would just do 63 times 2 to get angle, or sorry, arc RT. 63 times 2 is 126. Number 3, it's looking for the measure of arc WX. We've got to be careful on ones like this. It's not asking for WY, it wants to know WX, it wants to know that part right there. Here's what I would do. First thing I'm going to do is I'm going to figure out what WY is. Okay, that's kind of all I can do. If I have this 57 right here, I know that angle WXY right here is 57. Doubling that, or in other words, multiplying that 57 by 2 will give me the measure of arc WY. So 57 times 2 is 114. But remember, that's not what they're asking for here. They want to know what WX is. Well, what I can see here is that XY is a diameter. That means that major arc XWY covers 180 degrees, right? All the way from here to here would be 180. So if I just want to know this blue part, I'm going to say, what's 180 minus 114, right? If I take this whole thing and subtract the yellow part, it's going to leave me with the blue part. So 180 minus 114 would be 66 degrees. So this part up here is going to be 66 degrees. Example 4, I have an inscribed right triangle. That should be sort of a hint, but if it didn't say inscribed right triangle, if it just said inscribed triangle, the way I would know it's a right triangle is because I can see pretty clearly that PR right here is a diameter, right? And if you go back to the last page, the first thing we talked about is whenever you have a diameter in a circle, if you have an inscribed angle, such as PQR right here, that intercepts the angle created by a diameter, this has to be a right angle right here, right? Because the arc going from P to R is 180 degrees, right? Because this is a diameter. So if arc PR is 180, this inscribed angle is going to be half as big as that, and half of 180 is 90. So I know that angle Q right here has to be 90 degrees. So if I want to know what angle R is, well, first what I'm going to need to figure out is X, right? Because I don't know a number for P or R right now because they're expressed in variable terms, or actually in expressions. What I do know though is that if I add up the three angles inside of a triangle, I should get 180 degrees. So 180 is going to be equal to this angle R, which is 7x minus 1, plus angle Q, which a minute ago I established was 90 degrees, plus angle P, which is 3x plus 1. So I'm going to combine like terms. 7x plus 3x is 10x. Negative 1 plus 90 is 91. Negative 1 plus 90 is 89. Right? That's the same thing as 90 minus 1. So 89 plus 1 gets me back to 90. Subtract 90 from both sides because I want to get x by itself. Those two cancel. 180 minus 90 is 90 equals 10x. Divide both sides by 10, and x would equal 9. But I'm not done yet because it wants to know what angle R is. To figure out what angle R is, I just have to go back to the expression for angle R, which is 7x minus 1, and plug in the 9 where x was. So I'd have 7 times 9 minus 1. 7 times 9 is 63. 63 minus 1 is 62. So I'd have angle R being a 62 degree angle. Okay, last one. Have an inscribed quadrilateral. In other words, a quadrilateral where all four vertices are on the circle. Okay, so I know that these two angles then, since they're opposite of each other within the quadrilateral, they're going to be supplementary. And it tells me that angle B is 3y plus 4 and angle D is 2y plus 16. So I'm not going to set those equal to each other because I don't know if they're equal or not. What I do know is that they're supplementary. In other words, they would add up to 180 degrees. So I would say 3y plus 4 plus 2y plus 16, right? Both angles added together have to equal 180. When I go through and combine my y terms, I would get a 5y. If I combine my constant terms, I would get a 20. Subtract 20 from both sides. 5y is equal to 160. Divide both sides by 5. And y ends up being equal to 32. But that doesn't tell me what angle D is here. Right? I want to know what angle D is. The expression for angle D is 2y plus 16. So because I now know what y is equal to, I'm going to substitute that in here for y, or I'm going to plug it in. So angle D is equal to 2 times 32 plus 16. 2 times 32 is 64. 64 and 16 is 80. So angle D would be 80 degrees. This is angle D. Now I have to figure out angle C. Angle C. So here's what I know about angles A and C. I know angle C is 2x, and I know angle A is 58. The other thing I know is that those two added together, so the 2x and the 58, they're going to be supplementary. In other words, they're going to add up to 180. So I'm going to solve for x first. 2x. 180 minus 58 would leave me with 122. Divide both sides by 2. X comes out to be 61. Okay, but again, I'm not done because it wants to know angle C. Angle C is 2x. 2x is the same thing as 2 times 61. Right, because I just found that x is 61. 2 times 61 is 122, so angle C is 122.